Now that we've looked at WEP, let's take a look at the newest version of encryption for wireless networks, WPA. WPA and WPA2, which is also equivalent to 802.11i, is the latest security measures that you can have out there for wireless networks. They came out because of a lot of shortfalls of WEP. Repeated initialization vectors and weak RC4 encryption implementations made WEP very weak and made it so it could be easily cracked and wireless networks could be invaded. WPA uses a higher strength encryption algorithm. It uses the Advanced Encryption Standard, or AES. It also uses the Temporal Key Integrity Protocol, or TKIP. TKIP means that it switches keys out dynamically very quickly, so it very rarely repeats the same key, if ever. Now WPA, the first version, known as WPA, was introduced as a stopgap between WEP and what was then in draft. At the time, various industry organizations knew that we needed an improvement over WEP, so WPA was introduced. However, the 802.11i standard was in draft at that time. Now, WPA worked great, and when the 802.11i standard was officially ratified, it became known as WPA2. Now, WPA and WPA2 are fully compatible with each other. You can have networks that will talk to each other on different levels. The bottom line is WPA is much more secure than WEP is, and it's probably starting to get much more widely used. You definitely want to upgrade to WPA and WPA2 if you have newer equipment. Now, if you have older routers, older wireless routers, and older wireless cards, they may not support WPA or WPA2. Additionally, older Windows operating systems, Windows 2000 and below normally, will not support WPA also. You need to use WEP for those older systems. So if you have to use those systems, you're going to at least use WEP. If you want to use WPA and WPA2, you must upgrade. Let's go ahead and take a look at some WPA traffic. Okay, we've got some more wireless traffic here. We've got beacon frames and so forth. And I have one particular packet highlighted, number 220, that I want you to look at. Now we've got the standard frame data and IEEE 802.11 data. But I want to show you down here, whereas earlier we saw WEP information, now we're seeing TKIP parameters. And here's our TKIP initialization vector. You can see it's a little bit higher strength than a WEP, than a 24-bit initialization vector that WEP has. We've got some data in here that shows this is an encrypted packet. Now, you may or may not know, but encryption is probably the best measure against sniffing networks, against protocol analysis. And we'll talk a little bit about that as we go. But basically, it's very difficult to crack encrypted traffic unless you know the key or unless you can obtain the key by sniffing. And that's the case with WEP. That's why WEP is an inherently insecure protocol, because it sends its initialization vectors out in plain text, and you can get those and collect them over time and eventually crack WEP. So this is one example of a WPA capture using TKIP. In this next example, we have another capture, and in packet 8 you can see that this particular version of WEP, or WPA rather, uses 802.1x authentication. Now 802.1x is used to expand the authentication methods of the various devices on the network and to allow for things like smart cards and certificates to authenticate into the network. Remember that WEP and WPA authenticate boxes. They don't authenticate users. If you use 802.1x authentication, then you're able to also authenticate the user as well. 802.1x authentication is used primarily in larger networks. You usually don't find this set up in a home network. You might find it in a business network, so that you can authenticate not only the client to the wireless access point, but you can also authenticate the person on the client itself, the actual user, and maybe you're authenticating them later on to a Windows domain or something, but 802.1x authentication makes that possible. So we've got different parameters down here for the 802.x authentication. We've got the key, the NOTs, and the NOTs is basically a salt. If you're familiar with the Unix salts, a NOTs is pretty much the same thing. A salt basically is a starting bit or a randomization piece of information to help randomize your keys. So you've got all the WPA information here, and of course you're not going to really get anything out of WPA because it's encrypted and it's very secure. But this is just an example of 802.1x authentication traffic. And again, I'm not trying to make you a wireless expert during this course. I just want to show you an example of WPA traffic and before that WEP traffic as well.